Hello friends, this is Road to IIT and we are going to start a first chapter of physics, that is thermodynamics. See why I'm going to start this chapter, because this chapter contains almost 2 to 3 questions in JEE mains and advanced, minimum 2 to 3 questions. In If you are preparing for any GATE, say Maharashtra GATE, Karnataka GATE, Guj GATE, or any competitive exam which includes the physics, this chapter is going to help you a lot. So I am going to post almost 7 to 10 videos on this chapter, including a theory and past year competitive exams question. Okay, so without wasting our time, let's get started. So first of all, we have to learn some basic terminology which is going to be useful for in this chapter. So first of all, we have open system. So we can say open system is a system which can exchange both energy and matter with its surrounding. So this is an open system which can exchange both energy and matter. So if you want to say, let's say example of this. So a best example for this is you can say is if you are boiling a water in some basket, or in some you can say in some material. If you are boiling a water on a gas stove, you can see vapor which is going in the atmosphere, that is matter is transferring, and also a heat is going to be transferred from the bucket or say any bowl to the environment. That is both energy and matter is going to be exchanged from the system to surrounding. This is open system. Then closed system. Closed system, a system which permits passage of energy but not mass across its boundary. This is open system. This is a closed system. The example for closed system, you can say it's cooker. And the cooker, you will see the energy may be transmitted for a system to the boundary, out of the boundary to the surroundings, but the mass inside the cooker is not going to be transferred. Okay, the boundary of cooker does not permit the mass to be transferred. Okay, so this is a closed system. Then isolated system, a system which can neither exchange energy nor matter with its surroundings. See, a perfectly isolated system is not possible in the universe, because there is no material found which cannot permit permanently the energy and matter exchange with system to surrounding. Okay, but for a partial, you can say the water bottle is one type of isolated system for a particular time, which permits which does not allow energy or matter to exchange with system to surrounding. Okay, then surroundings, part of the universe other than the system. So if you are taking any system, if you are going to put you can say cotton in the soccer, then if you are say this is a system, then other than the system, all parts other than the system of the universe, that is surrounding. Then the boundary, anything which separate the system from the surrounding. If you are in the room, then the walls are in the room, you can say is your boundary. Then variables, state variables, the variables which are required to be defined in order to define state of any system, that is pressure, volume, mass, temperature, surface area. These are all are the variables which is useful to define the properties: pressure, volume, mass, temperature, surface area, etc. Then it is state function, property of a system which depends only on the state of the system and not on the path. This is state function, property which is only depends on the system, not on the path. This is called the state functions, which are the state function: pressure, volume, temperature, internal energy, enthalpy, entropy. Please remember this. In MCQs, these are going to be very useful. The questions can be there. Which one of the following is the state function? So pressure, volume, all are depend on the state, not on the path. If you are going from A to B, it is not going to depend on the path. It is from the point. It is based on that particularly point A and B. Okay. Then it's intensive properties and extensive properties. Intensive, that means which do not depend on the mass. That is called the intensive properties. Temperature, pressure and density, concentration do not depend on the mass. If you increase the mass, it is not going to depend the pressure and density, because density is the property of material. It is vary from material to material, not from its mass. Then extensive, which depends on mass, is extensive, that say its volume, energy, enthalpy, and entropy. If you increase the volume, then entropy is going to be increased. That means if you increase the mass, volume is going to be increased. So this is the extensive properties, which is depend on the mass. Okay. Then process, path along which state of a system change. This called a process. Say if you are in a solid state and you are going to liquid state, so the path which you are going to use is called a process. Then these are some basic processes which we all have to know. First of all, isothermal. Isothermal, that means temperature constant. Isothermal, that means temperature constant. Isobar, that means pressure constant. Isochoric, that means volume constant. And adiabatic, that means heat transfer is zero. No heat transfer. Okay. There are main three properties in the thermodynamics, that is P, that is pressure. If P is constant, then it is known as isobaric. Then we have V here. V, that is volume. Volume is constant, then it's called isochoric. And if the next one is temperature, that is T. If temperature is constant, then it's called isothermal. And if during the process the transfer of heat cannot take place, that means no heat transfer, then it is called adiabatic process. Okay. These are four important and basic processes. Then cyclic process and reversible process. Now what is a cyclic process? A process in which a system comes back to its initial state after undergoing the series of changes. That means, see, I am going to start it from this point and go from this point, and by reaching that point I am once again started and I come back to the original state. So this is known as a cyclic process. Okay. And reversible process, process during which the system always departs infinitesimally from the state of equilibrium, that is direction can be reversed at any moment. That means direction can be reversed, and this is the equilibrium process. This is a reversible. Base example of reversible process is quasi-static process, in which a process is divided into the infinite parts, and each part contains an equilibrium state. You can go to reverse direction at any moment of the process. So this is called a reversible process. Okay. So these are some basic terminology which we are going to use in this particular chapter. Okay. Thermodynamics. Now, moving forward in this, we have first of all Zeroth Law of thermodynamics. What is Zeroth Law? Zeroth Law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third, then they are in the thermal equilibrium with each other. Accordingly, thermal equilibrium between system is transitive relation. So what does this mean? That means if one body is, if you can say let's see, suppose here we have A here. A is a thermal equilibrium with C. C is here. A is thermal equilibrium with C, and we have B here. B is also in thermal equilibrium with C. A is in thermal equilibrium with C. B is in thermal equilibrium with C. Then you can say that A is thermal equilibrium with B. This is Zeroth Law. Now there is one interesting fact I want to know. I want to tell you that why this law called Zeroth Law. Why not first or second? Because this law is derived after the first and second law derived. Okay, so that's why they don't have the chance to name that first or second law. That's why they named it a Zeroth Law of thermodynamics. This is just a basic thing. If A is equilibrium with C, B is equilibrium with C, then A is equilibrium with B. A very basic thing. None of numerical is going to be asked from this law. Okay, let's move forward. Next is the first law. First law is the most important thing in the thermodynamics. First and second law are mostly important. So please focus on that. The first law of thermodynamics states that if the quantity of heat supplied to a system is capable of doing work, then the quantity of heat absorbed by the heat system is equal to the sum of increase in the internal energy of the system and the external work done by it. That means if a quantity of a heat absorbed by the system is equals to, that means quantity of heat is symbolized by the Q. Q is the symbol of heat. So Q is equals to increase in the internal energy. That means delta E, you can say that, or delta U plus external work, that means W. That means dq is equals to du plus dw. If we are taking a small amount, then dq is equals to du plus dw. dq is a heat transfer, du is equals to internal energy, change in internal energy, and dw is work. But as we all know, work is equals to P pressure into the change in volume, V2 minus V1, and we can say it as dV. So dW is equals to P dV. As we know that work is equals to pressure into the change in volume. So dQ is equals to du plus P dV. This is a mathematical statement of the first law of thermodynamics. Okay. dQ is equals to du plus dW. Please remember this. This is a very important thing to be remembered. And we can, from this, we can also say that the energy can neither be created nor be destroyed, but it can only be transferred from one form to another. See here, this energy, this internal energy or this heat energy is not going to generate it and destroyed, but this heat energy is going to be transferred into the form of internal energy or into the form of work. That means it cannot be created, it cannot be destroyed, but it can only be transferred from one form to the another. Please remember this. dq is equals to du plus dw. Okay. So now for this, for solving the numerical, the most important thing is the sign of dq and dw. That means work and the heat. Please remember this. If work is done by the surrounding on the system, that means if work is done on the system, as during the compression of gas, if we are going to compress the gas, we have to push a piston into the cylinder. That is, we are going to do a work on the system. If this thing is happening, then W is taken as positive. If W is taken as positive, so dq is equals to du plus W. And if, however, work is done by the system, that means in the expansion, the gas, if gas is expand in the cylinder, then pistons move automatically upward, and that means there is expansion process. So in the expansion of the gas, we can say that W is taken as negative because work is done by the system. So at that time the W sign is negative, so dq is equals to du minus dw. So please, this is a very important thing to be remembered. Okay, now let's see one basic example, not a hard, not a entrance exam level example, but start from the basic thing. Consider that 214 joule of work done on a system, again on a system. You can see here work done on the system, that means W is positive. Then 293 joule of heat are extracted from the system. If the 293 joule are heat extracted from the system, in the sense of first law, what are the values including the algebraic signs of W, Q and En? That means change in internal energy. Now, as we know that the work done is on the system, therefore the sign is positive. Similarly, if heat is adding to the system, then sign is positive. But here heat is extracted from the system. That means sign will be negative. If heat is added, then sign is positive. So if you want to remember this, you can remember this by this way, that if we are going to work on the system, then sign is positive. If heat is going to be add on the system, if the benefits from the system side, then we can say that it is plus sign. If the benefits on the surrounding side from the system, if the anything is going to take away from the system, then sign is negative. That is, we work done by the system and heat is extracted from the system, then the sign is negative. Here sign is negative for Q. Okay, now we have to find out the value of change in internal energy, that is En. So for En we have to use the first law. What is first law? First law is equals to delta internal energy is equals to Q plus W. Why? Because we all know that Q is equals to, here you can see in this part, Q is negative, Q is here negative, and we have to find out the delta du. So the formula becomes delta internal energy is equal to Q plus W. So minus 293 joule and 214 joule. That means sign is negative here. From the above observation, we can conclude that the internal energy of system would be minus 79 joule. Okay, delta E internal energy is equals to Q plus W. Here the thing is also that here we can use this formula. Q is equals to, by this formula we can also use this, dq is equals to du plus W, and du becomes what? Du becomes dq minus W. Du becomes dq minus W. Okay, but here as we see that dq is negative, so minus 293 plus 214, so it becomes minus 79 joule. Okay, so this is all about today's video. This is a very basic sum. We are not going to do with this sum because this is a very easy sum. This is not going to ask in any entrance exam because but just we have to start with the basics. So I just posted this sum. So this is all about today's video. The next topic is going to be posted on the next video. If you like this video, don't forget to share it and hit that subscribe button. Thank you.